Hello class, this is going to be our flipped classroom on properties of matter. As usual, it's recommended that you stop the video from time to time to copy down the notes. So let's talk about properties of matter. These are characteristics of matter. These are ways that you can describe what you are viewing when you're looking at different types of matter. And I'm breaking them down into two categories, which are physical and chemical. So when we talk about physical properties of matter, we're talking about things like size, color, texture, phase of matter, like solid, liquid, gas, density, boiling point or condensation point, melting point or freezing point. So in other words, I could describe an object like, let's say, this pen. I could say, well, the texture, it feels hard. I could describe its weight, its size, how long it is, how wide it is, the colors. It's a solid at room temperature. And you always want to mention when you're talking about phases of matter, what conditions, because obviously at different temperatures it could be a different phase. I can tell you its density, I can tell you what temperature it boils at or condenses at, what temperature it melts at or freezes at. And by the way, boiling and condensation point are the same temperature. Melting and freezing point are the same temperature. Then of course there are chemical properties. Now these are different. Chemical properties are things that cause the substance to change into a new substance. In other words, you are doing something to the chemical that makes it a new chemical. So boiling water and turning it into steam is not a chemical property because it's still water, just in a different phase. But if you were to burn paper, that would definitely be a chemical property, and hence a chemical change. Or if you were to rust iron, that would be a chemical property. So I guess the simplest way to put it is a chemical property is that which would cause a chemical to undergo a chemical change. I know it sounds kind of repetitive, but that's the easiest way to explain it. If you're saying, I've seen a chemical property, you say you've seen the chemical change into something new. So on that note, I want to talk about indications of a chemical change. There are four main ways you can tell that there have been a chemical change. One, a color change. So you've added chemical A to chemical B, and all of a sudden, a blue color appeared out of nowhere. Now, this is not the same thing as adding like food dye, because food dye already has a color. I'm saying you've added a new chemical, and where there was no color, now there is a color. Release or absorption of energy. In most cases, heat. So for example, if I add sodium to water, all of a sudden I see fire. Where'd that fire come from? Well, the reaction between the sodium and the water created enough heat that a flame was produced. Or there are certain situations where you add one chemical to another, and all of a sudden the beaker that held the chemical gets colder. It's absorbing the heat from the surroundings. We call these two types of absorptions exothermic and endothermic. So you may want to write this down. Exothermic means release of energy. Like you threw something in water and all of a sudden the water got hotter. That's exothermic. Endothermic means absorption of energy. You threw something in water and all of a sudden the water got colder. It absorbed energy from the surroundings. Formation of a gas is another chemical change. I threw something in water and all of a sudden bubbles appeared. There were no bubbles before, but now a gas has suddenly appeared. You formed a gas. And then finally, formation of a precipitate. Precipitate is one of those fancy words. See, I've underlined it. It means an undissolvable solid. It means I threw two liquids together, and when all of a sudden there was no solid, now a cloud appeared in the test tube, and when that cloud settled, I noticed there's this powder at the bottom of the test tube. Some crystals had formed. That's a precipitate. That's a chemical change. It wasn't there before. Last thing I want to point out, laws of conservation. Whenever you do any chemical reaction, three things must be conserved. First is conservation of matter, or more specifically, mass. What that means is if I started with 5 grams of chemical A and 5 grams of chemical B, and I created a new chemical, we'll call it chemical C, it must weigh exactly 10 grams. No more, no less. Because if you start with 5 and 5, you have to end with 10. You can't end with 9.9. You can't end with 10.1. It would violate the law of conservation of mass. There's also conservation of energy, because even though energy can be released or absorbed, it has to start from somewhere and it has to go somewhere. You cannot simply lose energy other than saying you lost it to the environment. The environment now has it. But you cannot create or destroy energy, just like you cannot create or destroy matter. And finally, the last one is conservation of charge, which we'll learn later in the year. Certain compounds have certain charges that they add up to a certain number. Usually that number is 0. When you start with a certain charge, you have to end with the same charge. So if you start with a +2, you have to end with a +2. If you start with a total charge of 0, you have to end with a total charge of 0. And that is our lesson.